What if you could give our entire planet a health checkup? I'm not talking about the land, but its lifeblood, the water in our lakes, our rivers, and our oceans. And what if you could do it all from hundreds of miles up in space? Well, today we're diving into some absolutely fascinating research on how satellites are becoming our planet's frontline doctors for water. Now, I know what you're thinking. This sounds like something straight out of a sci-fi movie, right? A camera way up in orbit, looking down at a river, and somehow knowing what chemicals are floating around in it? How is that even possible? Well, that's the central question we're going to unpack. For decades, the only way to test water quality was, well, the old-fashioned way. You'd send a team out in a boat, they'd scoop up some samples, and then run a bunch of tests back in a lab. And it works, but it's expensive, it's slow, and you can only cover a tiny little area at a time. But remote sensing, using satellites, it just flips the script entirely. All of a sudden, you've got broad coverage of whole regions, and you can monitor them continuously. It is a total game changer. But there's a catch, and it's a big one. Satellites are amazing at seeing things that physically change the color of the water, like a massive plume of sediment. The real challenge, and the whole focus of this research, is what we're going to call the invisible water problem. Turns out, a lot of the most dangerous pollutants are completely unseen from space. So to really get this, we need to split water pollutants into two groups. First, you've got your optically active indicators. These are the ones that are easy to spot. They physically change how light reflects off the water. Think of a huge green algae bloom or that murky brown water from sediment runoff. Then you have the optically inactive ones. These are the sneaky pollutants, things like excess nitrogen and phosphorus from farm runoff. They don't change the water's color at all, but they can be absolutely devastating to aquatic life by basically starving the water of oxygen. And that brings us right back to our big mystery. If these critical pollutants are literally invisible to a satellite's camera, how in the world do you measure them from space? The answer, it turns out, is brilliantly clever. You bring in a detective, a very, very smart one that can see patterns no human ever could: artificial intelligence. Researchers are using machine learning not just to look at pretty pictures, but to hunt for microscopic clues hidden deep within the satellite data itself. So how do you train this AI detective? It's basically a four-step process. First, you grab a satellite image of, let's say, a lake. At that exact same time, a team on the ground takes real water samples from that very spot. Then you feed both pieces of information to the AI. You show it the satellite's view and you tell it, hey, in this water, we found this much phosphorus and this much nitrogen. You just keep doing this over and over and over again, and eventually the AI starts to learn. It finds these incredibly subtle relationships in the light frequencies that happen to correlate with the presence of those invisible chemicals. Okay, so that's the theory, and it sounds incredible, but does it actually work in the real world? Let's take a look at how researchers are putting this technology to the test right now, all across the globe. Yeah, this isn't just a handful of scientists tinkering away in one lab. As this map shows, it's a massive global effort. We're talking about researchers on every continent collaborating, testing these AI models in all sorts of different environments, from the Great Lakes in North America to the Yangtze River in China. And this global approach is absolutely crucial for building models that are robust and can be adapted. And what exactly are they looking for? Well, this chart here shows the most wanted list. You can see total phosphorus and total nitrogen are way up at the top. So why those two? Because in high amounts, these nutrients are basically fertilizer for algae, and they cause these huge, choking blooms. When all that algae dies and decomposes, it sucks all the oxygen out of the water, creating these vast dead zones where fish and other life just can't survive. So yeah, being able to track these from space is a massive priority. The tools for the job are satellites you've probably already heard of. The Landsat program from NASA and the USGS has been our eye in the sky for decades now. And more recently, the European Space Agency's Sentinel-2 has been providing even higher resolution data. These are the workhorses making this whole revolution possible. And here's something really important: their data is provided for free, which allows scientists all over the world to jump in and contribute to this research. Now, it is really important to be realistic here. This technology is incredibly powerful, but it's not perfect. Not yet. This quote from the research paper is crucial. It basically means that an AI model that you train to perfection on a lake in Florida might give you complete garbage results if you try to use it on a river in Vietnam. Every single body of water is unique, so the models need that local, on-the-ground data to be truly reliable. So, where does this all lead? Keeping in mind both the incredible potential and the current limitations, what does this new capability actually mean for the future of our planet's water? All right, so let's boil it all down. What are the key takeaways? First, combining satellites and AI is giving us a revolutionary new way to monitor water quality on a truly global scale. Second, this is absolutely vital for tracking those invisible pollutants that threaten ecosystems and even our own health. But, and this is a big but, it's not a magic bullet. As we've seen, there are major challenges because these models need lots of local data to be reliable. So what we have is an incredibly powerful new tool in our environmental toolkit, but it's one we're still learning how to use. And that leaves us with a final and honestly a pretty profound question. As this technology gets better and better, we are fast approaching a future where we can see the health of almost every major body of water on Earth in near real time. With that knowledge, with that power to see, what does that mean for our responsibility to act? It's something to think about.